Hello, welcome back again to my YouTube channel. If you're new here, don't forget to hit the subscribe button, and if you're a returning subscriber. So from our previous video, we were talking about steel being among the 5 materials that can lead to cost overrun on sites. So today we are going to talk about concrete. How does concrete lead to cost overrun in construction, right? Like for instance, in this case, when we were talking about steel is more of like the skeleton of a building. So when it comes to concrete is now the flesh, like whatever gives the building structure, its elements. Like how do you look at the slab, like the thickness and all those things. When you look at the column, the shape of the column, there's a circular column, there's a square column, there's a rectangular column, and all those. So how does concrete lead to cost overrun in a construction project? Like with concrete, the way you lose money is actually invisible. You don't get to see it. So, for instance, if this cup of water is added into concrete, most probably you will say, like, it's not going to cause any effect, right? It's just a glass. It's just a glass of water. There's no impact that it's going to cause. Well, I know it's going to improve workability because with concrete, for it to be, for instance, if it's being pumped into a pipe or any circular section, like it needs to have workability. That means it has to flow easily from one place to another, right? But in this case, there's something that has been tampered with, that is the strength. So water in this case is a killer of strength, and it's going to affect the strength of the concrete. For you to test the workability of concrete, there's a test called slump test. Where
applications and types of slump. Concrete slump test is a measurement of concrete's workability or fluidity. It's an indirect measurement of concrete consistency or stiffness. A slump test is a method used to determine the consistency of concrete. The consistency, or stiffness, indicates how much water has been used in the mix. The stiffness of the concrete mix should be matched to the requirements for the finished product quality. Concrete slump test. The concrete slump test is used for the measurement of a property of fresh concrete. The test is an empirical test that measures the workability of fresh concrete. More specifically, it measures concrete consistency between batches. The test is popular due to the simplicity of apparatus used in simple procedure. Principle of slump test. The slump test result is a measure of the behavior of a compacted inverted cone of concrete under the action of gravity. It measures the consistency or the wetness of concrete, which then gives an idea about the workability condition of concrete mix. Slump test apparatus. Slump cone, scale for measurement, temping rod, steel. Procedure of concrete slump test. 1. The mold for the concrete slump test is a frustum of a cone, 300 mm 12 in of height. 2. The base is 200 mm 8 inches in diameter, and it has a smaller opening at the top of 100 mm 4 in. 3. The base is placed on a smooth surface and the container is filled with concrete in 3 layers, whose workability is to be tested. 4. Each layer is temped 25 times with a standard 16 mm 5/8 in diameter steel rod, rounded at the end. 5. When the mold is completely filled with concrete, the top surface is struck off leveled with mold top opening by means of screening and rolling motion of the temping rod. 6. The mold must be firmly held against its base during the entire operation so that it could not move due to the pouring of concrete, and this can be done by means of handles or foot rest sprays to the mold. 7. Immediately after filling is completed and the concrete is leveled, the cone is slowly and carefully lifted vertically, and unsupported concrete will now slump. 8. The decrease in the height of the center of the slumped concrete is called slump. 10. The decrease in height of concrete to that of mold is noted with scale, usually measured to the nearest 5 mm 1/4 in. Types of concrete slump. The slumped concrete takes various shapes, and according to the profile of slumped concrete, the slump is termed as 1. Collapse slump, 2. Shear slump, 3. True slump. Collapse slump. In a collapse slump, the concrete collapses completely. A collapse slump will generally mean that the mix is too wet or that it is a high workability mix, for which slump test is not appropriate. It means the water-cement ratio is too high, i.e. concrete mix is too wet, or it is a high workability mix, for which a slump test is not appropriate. Shear slump. If 1/2 of the cone slides down an inclined plane, the slump is said to be a shear slump. The shear slump indicates that the result is incomplete, and concrete needs to be retested for valid results. True slump. In a true slump, the concrete simply subsides, keeping more or less to shape. This is the only slump which is used in various tests. Two mixes of stiff consistence have a zero slump, so that in the rather dry range no variation can be detected between mixes of different workability.
So the more water you add into the concrete, the more you are diluting the cement paste, and the more you do that, when you realize, like after a period of time, for instance, if the concrete has been casted on site and it stays and the water evaporates, you realize that the slab will have either some pores. You realize some pores are going to be visible after some time, or rather the slab is going to behave like a sponge. You know how a sponge absorbs water and then it drains it off, because the water fills the pores and then so if the water is drained out of the sponge, you realize like the sponge has pores. The same thing applies to the slab. It's going to have some pores in it, so that if water is going to be put in it, the water is going to drain through it. With that happening, like you realize that the slab is going to shrink and it's going to crack, right? And for you to repair such a slab, that's more like you've already wasted it, right? You have to take it, remove it, and then you have to recast it again, right? And that is another cost. And one mistake that we make on site most of the time is when concrete comes on site, we just want to, like finish up with the concreting works, like cast it already, finish the work. But we are forgetting a very significant thing. Earlier, before I talked about slump test, right? It helps us to know the workability of the concrete before it's being cast. And when you conduct a slump test, you are able to tell, okay, if the water cement ratio in that concrete is perfect, right? Like it's not going to lead to some of those things that we discussed prior, like the slab going to have pores, cracks, shrinkage, that's what we are trying to avoid. So the very, very first thing that happens when the truck mixer comes to the site, the first thing that you should do is to test that. As an engineer, how much concrete do you need for your construction, right? For you not to overprice or overorder the amount of concrete that is coming on site. I know like most of us will actually take the volume of the slab and add 10%. I mean, we need to stop doing that, right? The first thing that we need to do is to measure the actual formwork dimensions on that day of pour. So when it comes to ordering your concrete, ensure that you order like 90%. So that when second to the last truck is pouring out, that's when you calculate the balance, so that you don't have to have like half of the truck being left with concrete and you still have to pay for it just to dispose of the remaining concrete. That is going to be a waste, right? So casting of concrete isn't just enough, right? I know you think like after you've casted, that's the end of it. Curing is another secret, right? Many a times we'll be like, it will just dry up, but there's something that you're missing in between that process of drying up. Like reactions have to happen. That's when you have to have that very like strong slab that can handle a live load of how many kilonewtons and the dead load itself. The mathematics there, you get me? Yeah, so if you just say like, okay, it will just dry under the sun, you're losing 30% of the original strength of that slab. For instance, if it's a slab, how do we now do the curing, right? And I know most of the people, they will say like getting the laborers who do the curing for a period of 7, 14, and 28 days, for us to attain the standard compressive strength of that concrete. Well, I would say that's costly, because sometimes that period where the curing process is being done, someone might say, okay, I need a break, right? And that gap, that's when the difference happens. Instead of using laborers to do the curing process, you can actually use the liquid curing compounds, which even saves, it's less costly, and it helps actually ensure that the process of curing is done perfectly and to the desired strength. So to wrap it up, as a smart engineer, I will say master the mix and you will master the project. So in our next discussion, we will be talking about formwork, another very key material that we fail to know how it's going to lead to cost overrun. So stay tuned for another episode, or rather another series of materials that lead to cost overrun on sites. So